Okay, I see it's recording. So hi everyone. Yeah, so as Christina mentioned, our goal here is to have a series of meetings to discuss different topics regarding the high availability in Dash and eventually come up with some standard defined protocol so that Dash appliances, Dash cards will be able to communicate their state to one another. So that's why we're all here. So a little bit more about why we need this is, as you can see, what we are changing with Dash is a path with which the packet is traveling through the network. So if we are disaggregating our state away from nodes that are running VMs to dedicated appliances, now it means that our path is changed slightly. It's not just going from one node to another. It will have additional hops, which are our Dash devices, and it introduces a new new points of failure, which are at the moment don't have any redundancy. So we of course have redundancy at T1, T2. Of course, we can have in T0 as well, as for example Microsoft is doing in Sonic with Dual Tor. But when we are introducing our Dash devices, this is we are running again into the issue of what happens when one of them fails, and how we can minimize the impact of such a failure. So this will be, I will try to keep this these series of meetings as interactive as possible, because the goal here is not to come to you and to present something that I think how it is supposed to look like, but I want to do it in a way that everyone provides inputs on different topics, and at the end of these meetings we will be able to converge to a protocol that will be that everyone will be able to support, and that will be open and provide interoperability. And I've gathered a few topics in here that I want to go over in the next meetings. So today we'll probably start with the requirements. There are some requirements already available in the Dash repository documentation that I have copied in here, and also I would want to get more input on every of these topics. Also to talk about end-to-end flows. How do we see this working in the real network? How all of the how all of the scenarios will evolve. The control plane interactions, of course, what is the data, what are the inputs from control plane, what information we should include, and so on and so forth. Of course, data frames, since we are talking about something that's supposed to be an open protocol, we want to define how our data traveling from one DPU to another should look like, and eventually just combine it all into a formal definition and present the result of our work to the wider Dash community. Yeah, so this is how I see these meetings moving forward. If you, by the way, have any topics that you think should be included into the future meetings, you can you can let me know right now. I will keep this presentation in edit mode. We can add everything that we think is worth going over, or you can just after the meeting, just I will of course send this presentation. You can just reply to me with stuff that you think should be added as well. Yeah. So, any questions about this high-level plan?
Yeah, I had a few things to add. Can I
Yes, Chris.
weigh in? Yeah, thanks. Thanks for this. Thanks for leading this too. Maybe a few other goals we could consider. One is, do we want a behavioral model or add this to the behavioral model? Because this might be modelable partly in P4 and partly in, C or something like that. And having a model of it might really help, might even provide some implementation start. Not just a model, but even I would say a simulation. We could have a simulation of two DPUs interacting, sharing their flow state.
Mm-hmm.
And so that's one idea. Another is we ought to consider the testing and observability of this and bake that in early, because once the thing's live and running, it's going to be a tricky thing to observe, right, and verify.
Mm-hmm, mm-hmm. Well, I think like testing and observability is something that should be a part of end-to-end flows. Yeah, that's a good idea.
And another goal would be we should study this in the context not only of the current DPU appliance model, but of the smart switch model, and make sure we don't overlook something, because that's coming down the road, right? The integrated smart switch, and we shouldn't forget that.
Oh yeah, of course, smart switch, and also other use cases. I think it should be extendable. We haven't talked about in Dash, probably because we haven't finished with VNet yet, but there is SLB, there is other stuff, and it should be extendable to those as well. Yeah, so I think this is also like smart switch. I think this falls under end-to-end flows as well. Smart switch, SLB, etc.
I made a couple of diagrams, new ones, in a pull request that I put in last week, and I was hoping for Microsoft to be able to review them at some point and see if they make sense. Because
so do you want to review them today, or do you think it's
we could look at them at the right time. I'd be happy to share my screen.
Okay. So I see. Anything else, or anyone else wants to add something?
So we have flow level high availability captured here. What about the intra-device high availability, right? Like in-service software upgrade, or what happens just as we do HA, how we handle HA in a switch. Dash device also should be able to handle HA, and that will be similar to switch for a single SmartNIC and be more complex for a smart switch.
So you're talking specifically about smart switch, or how the Tor interacts with the DPU appliance?
In the DPU standpoint, the high availability still has to work within the device itself, right? That's one thing. And then flow level, that is across DPUs, how we synchronize the flows, and how we if one of the devices go down, how we switch over. All of that is another flow level high availability. Within the device itself, like for example, if we have if we have control plane, we have Arc Agent, all of those, the subsystem of Sonic itself that will be running, including the Dash agent, Dash container inside the smart device, right? Dash device. The HA related to how all those components recover upon failure is a separate aspect also needs to be tracked. Are we tracking that here?
No. So what is with regards to Sonic, this is something that will be solved in another form. What we are focusing here is state replication across Dash devices, meaning that this is probably what you mentioned, synchronization of the state from one Dash device to another.
Mm-hmm.
All the protocol around it, control plane around that. We're not talking about, let's say, failures in the software stack that is not related to the state that Dash appliance keeps. So if, for example, something like Orc agent, Dash container, something like that, if some software component within Dash container fails, this is outside of scope of this working group. However, we can revisit those points later on. But software failures are not something that we are focusing right now because there are mechanisms in Sonic to overcome those, and also upgrades and all these things. What we want to focus on is the definition of the way how we can replicate a state of one DPU into another DPU.
It's fine totally to go through the flow part because that is missing right now. And then if it's handled in a separate forum, that's fine too. Or we can, continue this forum once this is completed to discuss the intra-device high availability in the Dash device. Yeah.
Yeah. So this is intra-device. So we're talking about replicating state of one device into another device. This is exactly our goal, but we're focusing on the state of the data plane, not what's going on in the control plane. Assumption for this working group, at least for now, is that no failure happens in the control plane, or almost no failure happens to the extent that we can allow that. So we want to replicate data plane, not the control plane.
Yes, flow. We are focusing on how the flows are distributed or maintained within each device and across and reconciled. That flow level, state level, the state that we maintain. Yeah. Okay. Yeah. We can maybe at some other time or some other forum discuss the rest of the higher level.
Yeah. So the rest is more related to the Sonic software stack. Right now, right now we're more focusing on let's say NOS agnostic stuff. Okay. So probably this stuff will be replicated into end-to-end flows as well. So I think today, our today's slot will allow us to go through the requirement review and clarification. I took the requirements from documents available in Dash repository, and also, as we already started, define what end-to-end flow types we are interested in, like some of them were mentioned in here, testing and observability, other stuff that we want to cover, and let's say define how we expect them to be working, so that eventually those expectations will be documented in the final protocol, and also how they will affect the protocol itself. Yeah, So if you don't have anything else to add, I will be also, as I said, this is kind of the presentation that will be updated on the fly. I will keep track. I will have this as the meeting notes for every of our session with the dates, attendees, and so on. So just for you to know, so that you can pick up from any place in case if you missed a meeting or joined later or something like that. Yeah, so let's jump into the requirements. Okay. As I said, this is just the initial set of requirements. I strongly encourage everyone to think of something that you believe should be included here as well. For now, I have only one item that we briefly touched upon. But let's go over what was already in the Dash documents and try to decipher this and understand how it affects a standard or a protocol itself. So first three are kind of from the same basket. They are talking about the how the failover should happen. We have some time constraints on the failover, so we should be able to achieve zero downtime planned failover, less than 2 seconds unplanned failover, and what are the implications on the Dash itself, and also ability to resume connections in event of both unplanned and planned failover. So let's start probably with this one. It is a clear, let's say, clear requirement. I hope you agree with me that we want to. Our main goal in here is to replicate all of the connections across 2 devices. So assuming we have active and we have a standby device, we should be constantly keeping the hot copy of an active device in our standby with all of the connection tracking present already, so it can take over at any point of time. And
Marian, sorry to interrupt.
Yes.
Very basic question. So the model we are going with the active and standby, not active, right?
As far as I know, unless
hey guys,
someone
Michael from Microsoft here.
Hi, Michael.
So hey guys, so I'm basically coordinating HA from Microsoft side. So I can tell you guys that currently the first version is like active standby. However, long-term vision, and if you are actually going towards it, we actually would like to have active, mostly because the active standby right now we are kind of solving with ASN prepends, and there is actually not enough TCAM space to kind of advertise and carry over different layers or TORs or the ASN prepend, so we'll be going towards active. So preferably the solutions should support active right now.
Okay, if we do active, then one of the requirement of hashing, complicated hashing, probably instead of
so so I know that from the source side, right, the connection will always go to specific device, right? So for a specific like 5 tuple, right? And this is also one of the reasons why we are switching most of the connection from NVGRE to VXLAN, and we are in process of doing this because there is just more entropy in the packets, and TORs can actually correctly hash it, because if there was NVGRE, there was not enough entropy in the outer header to actually do this. So yeah, you guys can assume that, for example, for a specific 5 tuple, the connection will always the TORs will basically should prefer hashing to one specific stuff, right? But as I mentioned, like this is active, right? So when the connection gets established, then the flow should be replicated to the other one, right? And the following packets can even reach the other ones, right?
And what is the condition that the packets will reach the other DPU in active-active scenario? What would be that trigger?
That trigger may be a Tor failure.
Tor failure. Mhm.
Right, because if there is no Tor failure, all the Tors usually basically will be the same path.
Mm-hmm.
So Tor
Okay,
failure
yeah,
or
that's-
link failure, this kind of stuff, right? That would potentially may rearrange and the packets may reach to other ones, right? And definitely the unplanned and planned, right? The main scenario that is actually customers are basically is required from a customer perspective is that if there is already established connection, right? Like since Synack fully happened, right?
Mhm.
Like this connection cannot be dropped, right? We can have a retransmissions, and the retransmissions basically happens when, for example, there is them like Tor failure, right? Or in this our case, like card failure or switch failure, right? But the connection must not get dropped once established, right? Because this customer don't like.
Mhm. Especially in such a massive
Yeah.
scenario where there were all of the connections served by this DPU for the VM.
Yeah,
It would
and
look
then
like
and
the
then
other.
one additional stuff when we are thinking from the scenario perspective, right? I was talking with the SLBs of software load balancing team on my side, right? And even right now, even though right now we are starting from HA, which will have two devices which will be paired with each other, right? We have data from the SLB team, which they mentioned that most likely to avoid some of the critical failures that they hit in the past, at some point we may need to expand it into potentially a ring of 3 devices. They'll be communicating. They basically mentioned that 2 may be very little to cover some of the scenarios. But right now we are basically starting with 2, so we should design for 2. But the design should keep in mind that potentially in the future we may want to be able to, if once we have built sufficient capacity or purchase sufficient capacity and place it, potentially spread into ring of 3 maybe in some configurations.
So Michael, that's a very different HA model. That's a clustering model then.
Yes, but this is still a conversation that's happening on our side. This was basically feedback when we had a review of the HA at Microsoft, right? There was the feedback from lead of the software load balancing team that said that they also started from 2 instances, and then at some point there was some live sites incident, and they had to basically scale out to minimum 3 instances for them to handle some stuff. And I think like if we start from 2, this is good model for now, right? But it's kind of keeping in mind that if we are thinking about one algorithm or the other algorithm, right? If we can potentially make it easy expandable to 3, right? Then potentially we have also solution in case we need 3 at some point.
Okay. Just one more question on the same topic. And that we might want to capture it as a requirement. So let's say the connection is learned on one of the active devices, and then it gets replicated, right, on the other active, or the active state is maintained on a where the connection is learned. So when we say, so are we expecting replication or, okay, so let's say there are n flows, so active 2 devices maintain n by 2, or n connections need to be replicated on both active.
I didn't fully catch the question. What is the n by 2? Meaning
if there are total 100 connections active, okay, and there are 2 devices which are in an active configuration. So my question is, each device maintains 100 connections, or they load balance and one device maintains 50 and another device maintains 50?
So from the point of view of the flow table, right, in order for them to successfully fail over, they will need to maintain exact copies, so 100 and 100, right? From the point of view of actual processing of the connection, right, one connection will most of the time, unless there is a failover or the switch or whatever, right, will end up always on the same device, right? So from the point of the CPS, right, this doesn't impact, this doesn't increase CPS by 2, right? It's mostly allow us to basically spread the the load, because basically some of the connection will land on the first active device, some of the connection will land on the other active device, right? But from the load perspective, right? But from the point of view of the flow state, the flow state will need to be duplicated in order to support the failover.
Got it. Got it. So basically, your requirement is that the flow state for all the connections need to be replicated on all the active nodes, whether it's a 2-device or 3-device configuration, and then the processing may be load balanced across these active.
Yes.
Right. Okay.
Processing will be for sure load balanced because, yeah, I mean, one packet will be going to one device only.
Correct. And should the processing be always on the node on which the connection was learned, or it can change?
Most of the time, yes. However, as I mentioned, like there may be some Tor failure in between, right? And some hashing algorithm will redirect it like to, for example, different Tor.
Okay, and then out of ordering?
Out of ordering, to be honest, if there is out of order packet, I think it's okay to retransmit this kind of packet and drop it. In case this, like I need to double check on this one. On our side, potentially we should have ability to forward some packets plus minus this kind of stuff, right? Why the out of order is the issue from the point of view of the fin tracking?
In flight packets, and when the hash changes, right?
I mean, yeah. So I understand that this may potentially happen, right?
Yeah.
I'm just curious. Do we have a strong requirement for the sequence numbers when putting the packets?
Right. That's where I'm coming from. Yeah.
But I believe that strong like the switches should just forward the packets, right? The only requirements for the sequence number is really from the point of view of sending ACKs and this kind of stuff, right? But this will be destination device that will be sending ACKs,
right?
Not the middle device.
Correct. Yes. Yeah. But just want to capture that, just to be clear.
Yeah, let's capture this and let's have an open item to this, right? And we can close on this one.
So Jai, how do you want to summarize that?
So one is that I think the model active standby, active, and 3-device active. Flow state need to be replicated on all the devices, whether they are in active or active standby mode. Flow which is learned on a node, active node, typically will be maintained on that node, but it's not guaranteed. And during the Tor failure,
I would say that in usual circumstances with no failures, it will be.
It will be, right. But during the failure cases, if it transitions, then there is out of ordering, and switch or the DPU will not worry about out of ordering. It will just forward the packet. But that's open item as per Michael.
Yeah, I believe we should not worry about out of order. We should just forward the packets, right? If the connection is established, right? The only way when we need the actual sequence number, I believe it's at the moment when we need to track the fins, right?
Correct. And I see Niranjan has some question.
Hey, Michael. So in the presence of NAT, there is no assurance that the forward and reverse directions of a flow will land at the same DPU, right? Your hashing is not going to give you any assurance that they will arrive at the same DPU. What is the desired behavior in that case?
Well, so in case because the flows are getting copied, right? So once the flow gets established and once the specific decision to use the specific port, right, is set up, right, this decision will, the switches will propagate the decision, right? So even if the return will land on a different one, right, then definitely will be asynchronous from the point of view, right? However, the flow will be there, so we'll be able to basically provide like a reverse transposition to deliver the packet, right?
You do, but do you want both of the DPUs to make independent decisions on each direction of the flow, or should one of them be treated as the owner?
I believe one of them should be treated as an owner.
Okay, so then there is a requirement that if a DPU gets a packet, that belongs to a flow for the other DPU, we will be forwarding it back to the other DPU.
I don't believe it's a requirement to kind of do two-hop model, right? Preferably not, if we can avoid it, right? Because this will reduce CPS, right? At the same point, the scenario that you are discussing is basically not scenario with the actual dynamic ports, right? We haven't discussed SLB yet. So I'm not quite sure if we should park this decision for later when we're discussing load balancing, because load balancing is an entire set of worms with regards to dynamic port allocation, ability for the customer to kind of control exactly. So that's explicitly one of the main reasons why we put the NAT out of the equation for now. And also most of the customers who are actually in the need of the high CPS, they usually have some firewall appliance that have dedicated, for example, IP address, and all the traffic to this IP address are redirected, for example, to this firewall appliance and this kind of stuff, right? Not many customers that are using NVAs are using this kind of dynamic port allocation. They usually assign the actual entire VIP to the appliance.
Okay. The reason I raised it because it has an impact on the solution, and if you intend to be forward-looking, this problem will show up at some point, right? It's similar to going to 3 DPUs in a ring.
Yeah. So I would say the state definitely we need to basically, because like when the packet goes out, right, for the first time, if you are talking about the load balancing, right, then some port gets allocated, right? But even though we didn't even want to even try talking about load balancing right now, but some port gets allocated, and this allocation for the specific flow, the specific port that traffic will be snatted to, right, needs to be replicated to the other device, right? So when the packet comes back, which may land on of course, like different device, right, we'll know how to do this reverse transposition, this kind of stuff, right? But the idea is no, I mean, we potentially want to bounce the first packet, kind of like multi-hop scenario in a way. For example, when the connection is established, for example, SYN is going, right, we can potentially do the same thing that right now the balancing team is doing. They are basically bouncing the packet across the ring. So usually for the SYN there, for example, the packet lands on the first device, they're bouncing this to the second device, they're bouncing the third device, they are bouncing the packet back to the first device again, and then only they put the packet back to the network. But all the remaining packets, they never bounce across all the devices, right? Because this will greatly reduce the capacity of the network and devices if they want to every single packet bounce, because there is no reason to. The state doesn't change, right? It's just for running packets using the existing already established ports that which were selected. So I'm not quite sure why you want to forward
Michael,
the
there's a
packets
slight
in the
difference
middle.
between what you're saying in there. In the SLB case, one of them is active and the other two are keeping the state. You are kind of getting an assurance that all packets of the session, forward and reverse, will end up at the same SLB. In this particular case, you don't have.
I don't believe SLB.
So let me just give you an example. Let me just give you an example of, and let's see what the desired behavior should be, right? DPU1 gets the SYN on a connection. You established it. Maybe there is NAT happening. You copied it over to a backup DPU2, or maybe you reflected the packet to a DPU2 and it created a connection. Now, the FIN is from the destination, or a reset from a destination shows up at the second DPU. Is it supposed to act on it, or is it supposed to send it to the DPU1, which thinks it owns the connection?
Yeah, so from the point of view of like a SYN, as I mentioned, like SYN needs to be, and the initial handshake needs to be basically most likely routed through all the devices, and the same with FIN, right? Because the packet also needs to like be kind of terminated to all the devices, right? So it's kind of similar also not only for load balancing but also for normal traffic. The kind of FIN most likely also like we need to communicate to all the devices that the state actually got removed, right? So those kind of like beginning and the end, those packets will most likely will need to bounce across all devices, right? And
but
I think in the middle, not.
Michael, but bouncing is actually the implementation of the protocol.
That's correct.
We may do it in a different way.
That's yeah. So I'm open for any changes there, right? But the idea is like basically the initial connection establishment, right? All the devices needs to be informed. The FIN, that connection is being removed. Yeah. Also, the other device needs to be informed, right? So answering your question, Niranjan, I believe the beginning and the end of the connection, definitely, right? from the middle of the connection of the packet just flowing, transferring data, right? Then I don't believe we need to impose any of those kind of requirements. What do you think?
Okay, let's take that as a working position and see if that has problems. And
yeah, definitely.
The other area where this is if you have non-TCP, like maybe UDP packets in there. And I don't know if you have a scenario of simultaneous open in your environment.
Simultaneous open. But you are talking again like a load balancing scenario, right? When you are dynamic allocating ports, right?
There is an impact on there is an impact on that, and also just for session management. I'm focusing just on session management to understand, what our approach is. And let's take the position that you stated that, that's what you stated for TCP, that SYNs and FINs are sent to both the devices, and then individual packets, either device is free to forward.
Yeah, that's true.
Who's going to ensure that SYNs and FINs are forwarded to both devices? I don't think that TORs are doing that.
No, TORs will not do it. This is like device will need to bounce the packet or kind of bounce the metadata, right, across the other devices.
Right, yeah, so metadata, of course. If we are defining this as a metadata, or let's say just notifying about the state change, then yeah. But I have a problem with saying that we are bouncing the packets themselves, because this means additional logic in the DPU that will ensure that only one of them will eventually forward the packet back to Tor.
Yeah,
so for me, there is a difference between bouncing packets and sending just a notification.
Yeah, so Maria, I will tell you why I believe the bouncing a packet may be required, but it's up to the community to decide that maybe we can optimize it, right?
Okay.
Because if we are just bouncing metadata, right, the thing is like you cannot positively acknowledge the connection was established and forward this kind of SYN on SYN ACK outside till you actually replicate the flow, right? Because then you are breaking the customer guarantee that the flow was already established, so there was full exchange on SYN ACK, right? And then one device dies, and then this flow dies, so customer connection dies, right? So we are breaking this guarantee. So in this case, we can only forward kind of the full SYN, right, to the customer, right, to basically the other entity, right, at the moment when we positively acknowledge from the devices they replicated the flow. Otherwise, we are breaking this guarantee from the point of view of the failover, right? And in order to kind of positively acknowledge this, right, you will need to somehow wait for this acknowledgement, which means that if you're only bouncing metadata, potentially it's okay, but then you need to queue the packet. And considering that it's like high CPS traffic, this kind of stuff, the question is, can you actually afford queuing the packets as you are bouncing metadata and waiting for the metadata acknowledgement, or do you actually want to bounce entire SYN packet, which will be usually very small because it doesn't carry additional customer data, right, with your own encoded metadata, so you don't need to implement queuing of those packets and then releasing those packets on the devices.
So, Marian, why do you say that bouncing the packet is the issue? I mean, flow will have a next hop information, right? And the flow which is learned on a different device from a FIN, and if we see a SYN, can have a next hop which is pointing to the other DPU? Is that not possible?
You have forwarding rules,
right,
for the given destination IP, that for that IP packet is supposed to be mapped to some certain public IP, and then if your resulting packet is the VXLAN with the public IP of that CA. However, when we are talking about bouncing packet, how do we bounce it? In that case, the PA should be PA of our DPU number 2 or our standby DPU. So
we can wrap the packets, right?
Sorry?
We can wrap the packet with kind of like encap it with VXLAN or this kind of stuff to bounce it.
Right, but this
local
is
encap, local encap can be done. But I think the main sorry, Marian, thing which is not clear to me, what you're saying is okay, let's take a specific example. A flow got a fin, got learned on a one DPU, but subsequent packets, the intermediate packets are going on a DPU 2, forwarding is happening, and SYN appears on DPU 2. Now, ideally, we want to bounce the bounce.
Is that a real scenario?
Huh?
Is that a real scenario?
Ajay, I think you need to invert the SYN and FIN in your example.
Yeah, right. Sorry, yeah. So the basic thing is that the beginning and the end need to happen on DPU 1. The intermediate packets happens on the DPU 2, right? If the end appears on DPU...
No, sorry, I disagree with this premise from the beginning. But we cannot switch back and forth from DPU 1 to DPU 2. We may have only one failover. Before that point of time, everything was going to DPU 1. After, it's going to DPU 2. How can we have, unless I don't understand something, how can we have some packets going to DPU 1, some of them going to DPU 2 for the same flow?
So that may happen in case there is a Tor failure, right? Or the link failure to some specific Tor, and packet on the physical network gets redirected to different Tor, which potentially may to different hashing of the packet at the end, because like at the end those devices are going to the Tors.
But that's not back and forth. It's still just one failover.
I mean, the device may recover in which case, and we also have link flapping at some point, which we are trying to catch. So those scenarios may happen.
Okay, so probably this is something that we are missing from. It's not like a single failover. Also,
so Marian, there are actually two different scenarios based on what you are raising. The first one is that the two directions of a flow end up on two different DPUs because of hashing, and this is without any failures in the network. It's just normal steady state behavior.
Hold on, but we are assuming symmetrical hashing.
Doesn't matter because the addresses will be different on the forward and reverse direction. One side may be tunneled, the other side may not be tunneled. So the outer 5 tuple may be different. You have no guarantee that they will show up on the same DPU.
Michael, is that true? Because I didn't have.
Yeah, that's true. Because those are physical network devices. Like for example, the edge device, which are getting traffic from the internet, like reply, right? Those are physical network devices. They will do their own hashing. We don't own any hashing algorithms there, and this kind of stuff, right? And it will just bounce the packet somewhere wherever the VIP is advertised. So indeed, the asynchronous
asymmetrical.
Yes, and most likely from the point of view of because like in case of VNet, we usually control both source and destination. In case of internet traffic, the destination is, for example, internet. So this may happen, right? This is when you involve load balancing traffic. And this is like normal behavior, right? That the ACK may arrive, for example, on different device.
Okay. Yes, so there was a comment, hold on, from Chris that we should make a list of use cases. I agree. This is the next thing that we will talk about. So probably starting next time, we will try to summarize all of these cases that we have asymmetrical flows. Because this is really something new to me. I was focusing mostly on VNet to VNet, where flows are symmetrical and landing on the same DPU. So if we're talking about asymmetrical flow, yeah, this is again something.
Yeah, Marian, I think we should capture it, but I don't see a problem. If the flow state is replicated, right, across all active nodes, then then eventually where the failover results in flow landing, right, it still will be forwarded. The only thing which I am a little bit not clear, Michael, you said that if there is a FIN packet, right, and then FIN packet should be bounced back to the node where the SYN packet came in, right? That's the requirement you mentioned. Is that correct?
Yeah, so the requirement is coming mostly from this, so we don't have kind of a state that is left over that will fill up the table that we somehow the other device will not know to clean, right?
Right.
Yeah.
Right. Yeah. And there, what Marian earlier made a point, which is valid, that flow forwarding is based on, some 5 tuple. Now, if we have to bounce back the traffic, then we may have to create another rule, flow plus fin, right? I don't know if that's what
Are you talking about the internal implementation of the
internal
view?
implementation. Internal implementation. Yes, you're right.
Yes, most likely, yes. You need to intercept, for example, the initial packet and the final packet. Yes.
Correct. Yeah. So that becomes a little bit tricky. So that's something we probably, Marian, we want to capture it as a separate line item too.
Yeah, and there is interesting stuff that we can revisit. Do we need to really capture the entire FIN-ACK and this kind of stuff, or just the FIN-ACK is the only packet that needs to be bounced, right? Because the question is like maybe we don't need to bounce the entire SYN-ACK connection handshake, right? The same FIN-ACK, maybe just FIN-ACK.
Right. Yeah, if there's a cleanup is needed, then FIN-ACK may be enough. Yeah, but you're right. You need to think it through.
From the forwarding point of view, the active-active pair can continue to forward from each side, but there is this aspect of control messages that need to be synced, and we invariably have all these intermediate hops where the TORs or other switches or links could fail, etc. And the assumption will become asymmetric, right? So the control messages sync has to be handled as a separate task, while the forwarding definitely can be done active across both the devices in each pair.
I hope there is no control plane synchronization. Everything is in data plane.
Yeah, control plane should not do anything here
yet. The messages, right? The control messages, like you were already describing, the SYN-ACK, whatever happens, right?
They should be in the data plane. They should be in data plane. They should not go on the control plane. We'll have a bigger problem.
They need to be synced. The state that defines the state of the flow, right? That has to be sort of synchronized between the two pairs, right? Even if they are in active-active or active standby, the forwarding side of things will fall in place and both can forward. But the control messages have to be relayed. Like if one of the two devices, right, are acting in the active-active mode for a certain set of flows, the forwarding part, I think we understand that both need to be done in one way or another, either it's active-active or active standby. But the control messages, if one receives some control message that affects the state of a given flow that both the devices are managing, it is required to sort of forward that control message to the other side so both are in sync. So I just felt that the control messages need to be synchronized.
Rishma, the SYN and FIN and all this stuff is not, at least that's not considered control packet. And that is, when you migrate a flow, to me, this is between two TPUs. This is equivalent to like migration of a large, VM, equivalent to a host like migration, as I could see it. But when we migrate a flow, the state of the flow is migrated with it, right? So there is no reason to kind of forward any SYN packets or whatever to get the state aligned or anything like that. And there was one more comment I had here. The window is 2 seconds downtime. Isn't that too much? Typically, you want to close your blackout phase within 200 millisecond.
Well, so the requirement is like less than 2 seconds. Like I'm all for basically much faster, right? For the unplanned, but the unplanned basically means that basically the device dies and somehow we maybe discover this too late. There's maybe some BGP propagations problem and this kind of stuff, right? So the requirement is 2 seconds. I don't want to impose like 10 milliseconds requirement. Like if you guys want, I can definitely tell it, right? But right now the requirement is like 2 seconds. If we can do, of course, like customer want to have complete not noticeable, right? But it's unplanned failover. which means that the device files, right? If during the 2 seconds there will be some retransmits, but the connection doesn't die during that time, right? That we all be noticing practices right now kind of acceptable from the customer. They still potentially want some RCA. On average, the 99 is much faster, right? But that's kind of unplanned failover.
Yeah. So would you want to put like two different requirements, then unplanned and in the zero downtime planned failure? I mean,
Yeah,
zero
so
is
planned failover is completely zero. It must be zero, right? So in a way, for example, if we need to service one device, like in a way update firmware there, and there is no way to do this like ISSU updates. So kind of like there is no way to fix the highway as the highway is running, but there is some big basically maintenance that we need to actually close entire highway, right? And kind of like redirect traffic the other way, right? Then this will be handled through control plane from the point of view that control plane will say, hey, for example, drain all the connections, like stop advertising BGP, wait for the connection to drain, right? And then, for example, give us information when you will see zero connections arriving on your device. And then this connection will be draining, right? There should be completely zero downtime for the plane failover, right? And then we will service the device. Then after we service the device, the control plane will say, okay, you can pair back and transition all the states. So the state should be starting replicating. In the meantime, we will see basically when we will get acknowledgement that the state was fully replicated, and then at some point it will be okay. Then let's start advertising the VIP back, right? So we can receive the packets, right? So planned failover needs to be fully zero downtime because we can actually orchestrate it fully.
Okay.
Okay, we have 5 minutes left. So there are two things. One that I want to go over a little bit more. Another one, which is Chris. Chris, do you think 5 minutes will be enough for you, or should we schedule it for the next time?
We can schedule it for the next time. I've just asked people to look at that pull request, and actually, I can just take 1 minute to show the diagram so people will be, and then we don't have to have a discussion about them now if we can restrain our enthusiasm.
Yeah, and a couple of things I want to add after that.
Sure, I'll make it as quick as I can. So people are familiar with this diagram, but from the spec, and it doesn't really show the smart switch version, which I'm trying to infer from the smart switch RFI. So I thought I should do a new diagram. Also, we don't have the source for this diagram. No one can find it. It's just a ping, and we want to be able to edit diagrams. So I redrew it with Draw.io. So now it's an editable SVG, and we can use it as a starting point for other diagrams. I didn't show the third appliance over here. I didn't quite understand it, but after this discussion, I understand we might want a third one. And then I added a smart TOR or smart switch variation where the DPUs are embedded in there. So this is just a starting point. Hopefully it can aid further discussion and further, specifications. So take a look at that. Let me know if you like them. We can merge it into the repo and then have it as a starting point for other diagrams we'll probably want for this working group. So especially if Microsoft could, let me know if this diagram is approximately correct for the smart TOR. That's all I wanted to talk about today.
Yeah, Chris, we might want to enhance it with a 3-node.
Yeah. I now realize I probably need to draw this one back in here and have something here, and then we'll need some guidance on how they'll relate to the overall.
Right.
So,
yeah, awesome. Thanks, Chris. So the third one on the initial diagram, I can tell you that it's kind of like a backup. So we were thinking to have kind of always some spare capacity with some percentage, which means because the device will physically die, right? So when the device physically dies, one device dies, but the connection on the left side are still maintained. But for example, like if there is connection on the left side, this card is kind of like orphaned, like it's a single one. So when it dies, everything dies. So we're thinking from the point of view of the OFR, if the device actually dies and it's non-recoverable, to have a set of devices always ready that we can pair this kind of orphan card versus orphan device with the other one. So we never run in the kind of single single failure mode, right? So
Right.
when it dies. So that's
I'll
the
put that in
purpose of
there.
the third device. Yeah. Awesome.
And I'm not sure
Michael?
how the third Tor would relate. Should it just be another Tor here wired in and with the same end goal of a third backup device?
Yeah, so we actually noticed from the point of view of how the data centers are constructed that most likely the traffic will need to go through T2, not through T1s. So the third device definitely will not connect to the same T1. It will need to go through the T2.
Okay.
Do you mean it will be geographically somewhere else?
No, the T2s are in the data centers.
It's still
Yeah.
in data center.
Yeah.
Yeah.
Hey, Michael, when Chris finishes, would you be able to look at his drawing?
Yeah, we will. They look
Yeah.
kind of almost like identical, like the original one. So I think they are fine, right? I will take a look more details.
Yeah, great. I'll yield back to Marian. So he had some wrap up items, but thanks for giving me the time.
Yeah, thanks, Chris. So the only thing that probably I want to do before we move on with the requirements is to ask Michael if you can probably next time present more data on how the asymmetrical flows should look like, because I think we also didn't incorporate that. For now, we were working only on VNet to VNet behavioral model. And there the assumption is that both directions land on the same appliance, on the same DPU. The same DPU will see the full handshake. I am interested in seeing what will be the implication of having the asymmetrical flow where it may land on different DPUs and how it affects both HA and connection tracking. So if this is something we can revisit next time, it will be good.
Yeah, I can definitely spend some time on this, but I think it's kind of like in the agenda would be probably not more than 15 minutes, because theoretically it is kind of like relatively, I think, one diagram kind of will show everything, right? So I think I can speak like for 15 minutes. Yeah. So we can schedule like 50 minutes for this. Yeah.
Yeah, and then we will continue with the rest of the requirements. Hopefully we'll close it by the end of the next meeting. Okay, thank you.
Yeah, awesome. Thanks, guys. Thanks, Ryan, for driving this and the interesting stuff, the requirements, right? As you are doing this in presentation, right? Will be good to later potentially amend the GitHub, right? So everything will be in one common location.
Yeah, of course. Everything that all the input that we gather in here, eventually the goal is to put it back on our Dash repository.
Awesome.
Okay, thanks everyone.